Hello, and good to see you guys again. Super excited for our second talk. Our first talk was super interactive and fun with Andrew, and this one is going to be equal or even more fun. Let's see. So we're very privileged to have David from Microsoft. He is the head of open source machine learning strategy. If you're familiar with Kubeflow or are involved in the community, he's one of the founders of the Kubeflow project and is actively involved. And today is going to be talking about how MLOps can be used to secure ML workloads. As before, we'll have slides for about 20, 30 minutes, and then we'll transition to Q&A. So with that, David, please take it away.
Hi, thank you so much. And thank you so much for the opportunity to present. I don't know how fun I'm going to be, but I'll certainly do my best to not bore you to tears. So as Manasseh said, I'm David Aronchick. I co-founded Kubeflow. I worked in Kubernetes for a long time, and I've been just absolutely overwhelmed by the open and welcoming of the machine learning environment as I come and do my best to help out in whatever way I can. I lead open source machine learning strategy at Azure, which means plus think about how to work better with open source communities, making sure that you're able to bring great solutions like ModelDB and many, many others to Azure and help them work in an effective way. And then also us helping external folks by doing commits upstream and so on and so forth. Our goal is really, we know how much machine learning and open source play well together, and we want to give them all a good home. The topic for today is all about attacks on machine learning. And the really interesting thing is that I titled this Owned by Statistics because none of the attacks here are the system not working exactly as intended. There's no buffer overruns or exploits, side channel attacks, you name it. This is all the system doing exactly what the system is supposed to do. And yet they can be very serious attacks against your organization. So diving in, I mentioned machine learning at Microsoft. It's something that we're very, very proud of. We have a very large research arm that's dedicated not just to working internally, but working externally. You can see some of the benchmarks and best-in-class models who've contributed back, and then obviously others have built on top of us and beaten us since in many of these. And machine learning really does innervate almost every product at Microsoft. You can see all the various consumer and enterprise, embedded, hosted solutions, all that require machine learning. And the reason is because the data that we have to pour through to help make our customers' lives better is so large. The number of people interacting with ML-powered Office, the number of questions asked of Cortana, the number of security events we evaluate every single day are so large that without machine learning models, this would be simply impossible to build a rule-based system to address it. So this is the kind of thing where we talk about it, and it sounds great, but then when it comes to how to build this for other folks, they are usually just presented with this, right? It's very, very hard. And one of the biggest reasons is no matter how many times we publish a notebook or a Python file or something that includes the model itself, the model code itself, we oftentimes tend to breeze over the fact that machine learning isn't just about building a model. It's about all these other elements put together. The way that you ingest, the way that you transform and train, track training over time, tune, and then, of course, roll out your solution and monitor it at scale. And that is what MLOps is all about. Now, let's say you're a data scientist. You're like, well, I don't really care about that. And I would propose you do. And the reason you do is because of tweets just like this, where you can have a phenomenal solution. It could have been developed very quickly in 3 weeks, and yet 11 months later, it's still not out the door. And this is the kind of thing we hear all the time. And it's most often because of the separation between data scientist and production environment. Oftentimes that can be very, very wide. The Jupyter Notebook, the local environment, things like that are great for developing a model, but not so great, or not, it goes out of line for a lot of the things you would do when you bring it to public. MLOps is designed to bring those two together, where on the left-hand side, you have that very quick iterative loop, and you're able to go and develop machine learning models that make sense, that have good accuracy, good area under the curve, low loss rate, and so on. But then you're able to fold that into your standard GitOps pipelines of development and operations of the rest of your application. And you're able to do that with a very low cliff that just flows over one way to the other. And that's most often because of a meeting in the middle, where we bring DevOps and to the left, we help them make it an easier landing spot by incorporating tools and things like that that the developers are using. But then at the same time, we help machine learning data scientists come to the right and help them build very quickly, but do it still in a more production-ready way. And you can see some of these benefits that you might get: observability, automation, validation, and reproducibility. All very core issues to machine learning, and MLOps really helps provide them. Now, you may ask, wasn't this talk supposed to be about security? And what I would like to posit to you is that MLOps is the basis for security. And you're like, well, but it's just math. How bad could it be? Well, let's show you how bad it'll be. The three types of attacks I'm going to talk to you about today are: an attacker gets your ML to lie to you, an attacker takes your models, and an attacker finds out about hidden data. All very easy to discover via machine learning today. So let's dive in. Your attacker gets your ML to lie to you. Well, let me give you a very trivial pipeline example and walk you through where the attack vectors might be. So first, let's say you have a very simple step here where I'm going to ingest a bunch of data. Then I might engineer and split that data into two sets, a training set and a testing set. I take that, I do my training, potentially at scale, and then I package and serve it out to an endpoint. Now, in this case, I'm building a very sophisticated model. It's called a circle detector. I want to be able to get a picture and detect a circle. So the first thing I'm going to do is collect a lot of examples of circles. That's very important. I want to train my model and to make sure to be able to detect them. And then I'm going to ask my users to submit a picture of something, and I'll tell you whether or not it's a circle. So here you go. You can see it. It's this is the picture here. And inside there's a purple circle. Let's see what it says. It says it's a circle. Fantastic. I win, right? Well, what happens when I do the next step? Now a user is submitting something and it's got a square in it. And I'm like, well, this obviously should fail, except it worked. It still says it's a circle. And you're like, well, what the hell's going on here? These look completely different. One's green, one's blue, blah, 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 blah. How could this possibly be the case? Well, it turns out that every pixel that is representing a circle is also represented inside a square. And so the model looks at it and says, well, it's got the same pixels. All those pixels line up. This works. The failure here is that I didn't do a good enough job indicating not just positive indications, but also negative indications, so that my machine learning model could understand exactly what's going on. Now, you say, well, all right, this is a toy example. This wouldn't really happen. It turns out that this does happen all the time. So here is a wonderful paper, and don't feel the need to write down all these. At the end, I have a list of all the papers, and you can take screenshots to your heart's content. But this is a wonderful paper where they do a wolf versus a husky detector. And you can see here that, that it did pretty good. Only one mistake. That's fantastic. Well, it turns out that if you start to look, and this is using some of the great tooling we have now around explanation of models, you can see in the ones where it's detecting a husky, it's actually capturing, oh, okay, this is a husky here, and it's capturing the eyes and the leg here. But when you look at where it's detecting wolves, it doesn't capture anything, right? It's just basically the outside of it. Here, at least you get a leg, but this doesn't have any wolf at all in it, neither this and this. And when you look even deeper, it turns out that I'm not even detecting a wolf at all. I'm detecting snow. That's because that happened to be where we took all these pictures. And that's why we made the mistake, because this was a husky And it tried. Here you see it got the lower part of the lip, but at this time, it found the snow and it felt that that was a more accurate representation. Now, obviously, again, we're still in the toy, but now things start to get bad. Here's another paper where using generative adversarial inference, where you take a number of examples and you keep trying to train against that model until you're able to get the model to lie to you. Here, in this case, on the left-hand side, we applied stickers to a stop sign. And as a result, it reported that that was a speed limit sign. So if the self-driving car was supposed to stop, it now won't. And in this case, on the right-hand side, we have a turtle, and we 3D printed a shell on top of it. And that shell was especially crafted so that it would come back as a rifle. And again, you're like, well, how bad could this be? Well, now we have all these things where you have automated face detection and law enforcement agencies that are using these things to detect crime. In this case, AWS's face recognition system falsely matched 28 members of Congress with mugshots. So now, somebody could be just entering a stadium, and they could be arrested or at least detained because of this false match. And the worst is, it's not even that easy to opt out. Here you can see a reporter went through and tried to opt out of the face recognition system at an airport and wasn't able to. So this is where you're really starting to get into a situation where if you are able to adversarially attack these models and get, understand what the model is looking for, and then be able to detect them and violate what the construct is, you're now able to get it to misbehave and potentially cause real damage. So are you terrified yet? There are lots of ways to defend in this particular case, and you can do it with more edge cases. You can add more bad data in there to try and adversarially attack yourself. You really need to focus on your evaluation metrics. Make sure you're not just looking for snow and using a number of different models to test your data. You should absolutely have your own red team and spin up that red team and have them attack your models and your entire system yourself, and we'll get into some of that in a bit. Also doing a lot of alerting and monitoring. If you're seeing things out of the norm, out of the statistics that you've normally seen, that's something you should do. And this is probably one of the most important ones, which is continuously taking your production data, bringing it back to your training data and your ingestion, and folding that into your model to make sure that you're continually improving. And to build a pipeline, it's pretty straightforward. What you're going to want to do is, have a CI/CD system. Could be GitHub Actions, Jenkins, so on and so forth. Then you'll add modular components, just like ModelDB. You'll want to have a place where you store all your metadata. You'll want to add automated tools to go and attack your models yourself, and so on. And then this last step, which is really measure, measure, measure. As fast as you possibly can, continually measure and continually update. And this is really where it gets to the point where MLOps is so critical. If you can't go and rebuild and retrain your model with a single push of a button, you're going to have a bad time. Because at some point, at some very inconvenient spot, something is going to go wrong with your model, I promise you. And your ability to react quickly to that is incredibly important. And I love, this last phrase is the most important. Don't let your adversaries be the ones to alert you that your systems are out of date. Because they're not going to alert you, number one. And number two, there's always going to be a time where you need to update it faster before something has been publicly exploited. And so your ability to do that quickly is incredibly important. To walk through why modularity is so important, just very, very quickly, a standard MLOps pipeline might look like this. Maybe you start with something like VS Code or Jupyter or something along those lines. You check into Git, and then you kick off your CI/CD pipeline. And the CI/CD pipeline is going to be quite modular. You're going to want various steps. In this case, this is a multi-step process, which does processing data, then feature engineering, which it does on an external service like Spark, hands it back, then it maybe does training, maybe it uses something like Kubeflow to do the training, then a simple packaging step, which might occur on the runner, and then actual serving of that model. Now, the incredibly important part is not just having this pipeline, but also having a common metadata store where you can write the results of all of these steps. Because unless you are able to go back in the future and recreate and understand exactly what went on, you're going to be in trouble. Now, again, the value of the modularity is really powerful. So let's say, for example, we took the explainer that was provided that helped us understand what went wrong with that Husky model. And in this case, we add that explainer over here. Maybe it's running as a service. Maybe it's another component that we add. If I've done this in a very modular way, I'm able to, add that explainer externally and then just run that very, very quickly. And this is where, your folks who are designing these massive Jupyter notebooks that have, 400 cells in them, that's going to be a real problem, because those are the kind of things that are hard to break down. They're hard to add arbitrary steps into, and so on. And when they do, you could have something, entered at cell number 100 and have it break at step number 300, and all you see is that the entire thing failed. Knowing how these things break down is incredibly important. Okay, so that's an MLOps pipeline. That's getting your model to lie to you. Let's go on to the second attack. An attacker takes your models. So models are obviously incredibly important. They take a huge amount of resources to build and train. These are very hard to defend against completely, but they are possible, and MLOps is often the best way to do it. So in this case, we're going to talk about two attacks. One's called a distillation attack, and one's called a model extraction attack. The distillation attack is pretty straightforward, actually. In this case, let's say I have a model over here, and it's a black box. I'm an attacker, and I start to probe the model. So what I'm going to do is I'm going to keep giving it examples. And so in this case, I handed a heart, and it says no. I handed a little pentagon, and it says yes. And then I handed a lot of examples, and it comes back with a lot of results. And then I handed a whole lot of examples, and it comes back with, pretty clear result. Anyone want to guess what this is? This is a Nina Simone detector. No, it's not actually. It's obviously a triangle detector. But by doing this, by attacking it with all of these various examples, I'm able to go and recreate that model, because now I have a whole bunch of examples, and I can use this as my training set for recreating the model myself. And that means that now, instead of this population going over and using the original model provided, they can use mine instead. Now, it's not necessarily you're going to do this for commercial purposes. Oftentimes, this is just a foothold for going and getting more sophisticated attacks over time. But regardless, I think we can agree that it's not great to have your models leave and never touch you again. Now, the question is, how accurate is this model, right? I didn't have access to the root thing. What happened? How long does it take to get to 99%? In this case, there's some great research out there that shows that it's actually very small. In this case, to do a full decision tree survey representation was only about 4,000. And here to recreate the digits and adult logistic regression ones from AWS was under 2,000, which is a really small amount. With a model requiring about 5,000, that would take about 2 queries a minute for 2 days, which is almost effectively impossible to measure. And the reason it's impossible to measure is it looks exactly like end users. Now, you can do your best, and you can certainly try to defend against it. But let me tell you, it's not hard to spin up a VPN and query from 5,000 different IP addresses. That's pretty straightforward stuff. And a sophisticated attacker that's basically nothing to do. So that's distillation. A model extraction attack is even more sophisticated. Boy, when you go through and you read these papers, and I'm just absolutely floored at how good some of these researchers are. So creative. And this is one of my favorite ones. So this one, we're going to explore BERT. BERT is one of the most popular, it was absolutely transformational work out of Google, a new language transformer. And it backs many of the cognitive services that you see on the web today. These are Azure Cognitive Services. We have a more sophisticated one, but it was certainly based on the BERT research, and we were able to take it and improve upon it, but the same kind of attacks will apply. So in this case, there's a detection tool called Squad that tells you how good your model is. Very, very sophisticated stuff where basically you give it a corpus of Wikipedia articles in this case. Actually, Squad already has that. And then you ask a question of it, and you say how good the answer is. And in this case, you say how many instruments does Prince play? It says 27. And it's able to go through, figure that out. Here's the structure of the sentence, and it understands that and gives you a response. Here are the papers that talk about the attacks. Again, all the papers will be listed at the end. And you can see here you can do a random attack where you actually just hand it random words and the model responds. Or you can do a wiki attack where you take some of that original corpus and you attack it again. And in this case, you're able to get very, very good results. If you attack it as many times, like a tenth of the time that you had for the original training, you're able to get 72% accuracy where the original accuracy was 84%. If you do the exact same amount, you're already able to get up to 86%. So again, that's not good. You can try and watermark, you can try and do other detection of query attacks, but really the pipeline is the value. Being able to spend your time here, continually improving, updating, and so on, will pay off huge dividends, not just because the attackers probably aren't going to be able to spend the same amount of time here, but also because that's just going to make your models better. So I would spend the majority of your time on your left rather than on the right. Okay, and now we'll talk about hidden data. The interesting bit is that you were probably already leaking hidden data before, and ML just kind of called it to the front. And the way you were often leaking it is something like this. Maybe here's a Waze, and it's giving me a suggestion where I'm going. Here's my network graph saying who I should follow. And in this case, it's not even looking at my data, it's looking at my friend's data and leaking it out. Now this is public, but like you can imagine private things happening too. Maybe you're getting recommendations on where to go for runs, and behind the scenes it's leaking the information about what's going on and where people are already running, and that happens to give me the evidence of a private base here. So again, this can be very standard. But there's nothing so bad that it can't be made worse, especially with ML. And what you see now is another really interesting paper called Secret Memorization. In this case, it's unfortunately not going to come through because of the coloring on these slides. But the idea is you can see here you get the start of the sentence, and I probe against that, and then it proposes the rest. And that this is leaking my private corpus of information. Now, the problem here is, of course, if it's doing its job, it sounds exactly like me. And that's wonderful. But the problem is that if it gets into any adversary hands, now they have access to effectively my corpus of data, and they can probe against it. And you can see how they do this here. Like I said, unfortunately, the coloring didn't come through. But think about the left-hand side of the sentence. Maybe it's my address or my visa or my social security number. And you stop, let's say, right here, 262. 262 is a known data point, right? That's how you social security numbers in Florida start with 26. So if I probe with nothing more than 26, it may suggest the rest of the social security number. Don't look at these. These are all fake, I promise. But you get the idea. So the model is representing this well. It's convenient to me, but unfortunately, this is where data leaks. These folks at Berkeley and Google Brain came up with a really interesting probe to figuring this out, where basically they figured out a way to automatically probe into your training data and then detect for that leakage at a later point. And so by probing, by submitting this as the data and then submitting just the beginning of it and seeing whether or not the sentence was recreated, you're able to do it. Now, the danger here is it's just detecting. It's not preventing leakage. It's just detecting leakage, which means if you let this go out to production, it's highly likely that something's going to leak. And you get into some ways to defend against it with things like differential privacy that prevents, very generic attacks. But it's still, if I'm able to simply take over this person's account for the purposes of suggestion, not their private, email or anything like that, just the purposes of suggestion, I'm going to be able to get access to a whole bunch of their private corpus. So ultimately, things will leak. Again, the point is to make it sound like it's accurate and leak, but the sooner it gets to, the closer it gets to sounding exactly like me, the more you're probably going to leak. And you have to really understand where your exposure is and how to defend. So the summary is, MLOps gives you a lot of ways to defend against these things. It's not free. You're going to need human work. You're going to need a red team thinking about all the ways that this is bad. But most importantly, it's that how do you build a single button that takes you through all your entire pipeline of training and lets you really flesh out what's going on and recreate what you need in order to recover quickly. And I always like to end my talks this way. It really is a brand new world. And as much as I love ML and all my ML brethren, all of you are not the people we need to put these tools in the hands of. It's really the next step. You are building the tools that will change the world for the better. The frontline healthcare workers, the people, professors looking into historical bias and other issues, economists who are looking to figure out ways to improve income inequality and so on, tax systems and all those kind of things. The tools you're building need to be thought through extremely carefully because they are absolutely not going to understand what's going on behind the scenes, and it's up to you to help defend. But you cannot avoid these things. Your pipeline will be attacked, it will have issues, and the game is all about how to mitigate and how to quickly recover. And as promised, here are all the papers. Feel free to take screenshots. You're also welcome to send me an email. You're welcome to send me a tweet. And you can see a number of actions that are designed to help solve this on GitHub with MLOps-GitHub there. And with that, thank you so much to Verna and ModelDB and Manasseh and all the folks. Back to you.
Awesome. All right. I was furiously scribbling notes. The researcher in me was so excited that, the stuff that we just write in Europe's papers is now having an impact in the real world. So I'm super excited, not because ML can cause problems, but because some of the work that was very out there is now becoming actionable. So thank you so much for that. We're beginning to get questions already. Let me start off with one that I think is on several people's minds. At what time should you start worrying about ML security? Is it day 0, day 1? When do you start thinking through these challenges in your team?
So, obviously the glib answer is if you're not thinking about it, it's already too late. But I want to be honest, a lot of people look at ML as a completely different thing. And the reality is it's just software, right? You have understanding of your threats for your existing software. So, for example, if you have a database, right, completely not related to ML, if you have a database, it is highly unlikely you're going to nakedly, open it up to the internet. No, that would just be insanity, right? There are free attacks and so on and so forth. They can get all your data. Of course, you wouldn't do that. It's easy to think about ML with the same kind of framework that you would think about anything else in your environment. So if this is a private model that just does batch inference against private information and gives you scores for particular entries, your total attack, surface area is pretty small, right? It's not to say you're security free. You should absolutely be thinking and having a red team and those kind of things, what these particular problems are. But I would argue that you really should always be thinking about this stuff holistically. What is the security of your inbound data? What's the security of the things running in place? What's the security of how you're exposing that to the world?
Got it. Awesome. So we have one audience question that has to do with the nature of ML. So it says, how do you imagine we can handle the statistical nature of ML? Are things like Canary that Devops folks usually do, are they a good fit here? Or how would you change that?
No, I think it is absolutely. And it's one of that early slides that I showed there, where you have the MLOps researcher and then the developer and then the operations. Unfortunately, today, one of the biggest challenges that we have is that we put those data scientists out on an island. And even when they do have pipelines that they use for themselves, they're completely detached from everything else. What you really want is these people are software developers, just like anyone else. And though they're using Jupyter instead of whatever, VS Code, actually they could use either to do either, but you get the idea. Like, though they're using different tools, don't think of them as separate. You really want a solution that solves for everyone. And so you're going to want, for example, a package evaluation system. Should this package be in our environment? You're going to make that evaluation whether or not it's someone working in C or Go or Python or R, right? And so those kind of things, you're going to want to use those same things. Now, going back to the question of things like canaries, you're going to use a canary for your regular software development. You should absolutely use canaries for your MLOps pipelines, and you can see how to do that. Go read that paper; it really is wonderful about how to do that. Some examples with the secret memorization. By the way, that paper works wonderfully even if you're not doing natural language generation. It also works just generally.
Got it. Maybe I'll pick up a question that was asked in the previous talk, which is super applicable here. Like, where do you see DevOps and MLOps overlapping? Will MLOps get kind of subsumed by DevOps? How should we think about it?
Yeah, I mean, I just think MLOps, like SecOps or InfraOps or whatever the hell else ops you have out there, they're all special cases of this general philosophy, DevOps, GitOps kind of thing, which is, can you give the people building the thing a declarative way to structure the rollout of the thing? So what happened, for many, many years was you would have someone on the way left-hand side doing a bunch of stuff, and then they'd throw it over a series of walls before it got out to production. And the purpose behind something like GitOps is, no, actually what we're going to do is we're going to have that person on the left-hand side be declarative about every step in that process all the way to production. So that person on the left-hand side can say, oh, you know what, this needs a GPU to run, or this thing only will work if it's run in the, whatever iris zone, or, this is going to need a machine that has 8 gigabytes, or it's going to need 5 nines, whatever it might be. The point is that person has as much knowledge about anything as they are going to want for rolling out the entire pipeline. But at the same time, that doesn't mean that SRE is out of the case either. The two of them need to collaborate together so they take into account both of their requirements, but have those requirements all the way at the left-hand side. And then everything else is driven by automation and declaration.
Got it. Throughout your talk, I think the one thing I took away was like pipelines for the win. Can you maybe bring that back home and maybe summarize, like, why do you think pipelines or repeatable pipelines are the key to solving these challenges?
It's funny, that word repetition is probably the one where I would anchor the most. You being able to arbitrarily repeat a pipeline is incredibly powerful. It gives you portability because theoretically you've declared exactly what that environment is. So you can do it anywhere. You can do it in this environment, that environment, so on. You know exactly what was written. You wrote out that language of how you ran this thing to an immutable store. So you're always able to go back and say, this model was produced by this pipeline over here. But then you're also able to do a lot of things like static analysis against it and things like that. So you can do evaluation of these models and pipelines and steps and so on and so forth, before the thing has even rolled out. And that's powerful as well. So, being very declarative and having systems that understand how to push this all the way through is really the secret sauce.
Got it. It seems like having a repeatable pipeline lets you react faster than like, oh, how did I even build the model in the first place?
Yeah, exactly.
Perfect. Another question. ML security today seems a lot like security by obscurity. we see efforts to enable privacy by design in ML. Do you see getting provably secure ML, or will we be stuck in obscurity as our mechanism?
Yeah, it's interesting. I definitely wouldn't say there's any obscurity going on right now, right? Models are completely open as they stand right now, right? There's almost no ability to lock a model down. I mean, even like I showed you, even if you put it behind an endpoint, you're able to recreate it almost instantly. I mean, imagine being able to just by bouncing a ball off a bank vault's wall, or the wall of the bank building, 5,000 times, I was able to tell you the exact layout of the vault and the combination inside. So there's almost no obscurity to it. But that's effectively what's happening in ML. As far as being provably secure, the challenge is, I mean, obviously I'm not a mathematician, so I'm not going to get that right. I'm also not a professional security researcher. Please go hire a red team and have professional security people on staff. I'm not going to be able to dictate whether or not something can get provably secure. Can you detail the attack surface area? Can you say what risks you have involved, what is PII, what's not PII, what you find valuable, what you don't, what you're going to open up to arbitrary queries versus what you need to keep private? Of course. And that's the best you can do, because it's so many points. And let's go back to that natural language generation attack. In the best possible case, it leaks 100% of your data intentionally, right? Like, it sounds exactly like me, and it's recreating my voice, and it's doing exactly what I want. Like, there's nothing about that model that's wrong if it's leaking 100% of my data. The problem is how do you constrain that, right? Now, in this case, you have all sorts of security endpoints and things like that you would put in front of it. But if someone got access to that private trained model, they basically have my entire email inbox.
That's very fair. Yes. So I'm guessing you're not a fan of Smart Compose from Google.
No, that's the thing. We're going to, this is great. It really is. And I really am a huge fan. I certainly know the Google security people, they are geniuses, right? But they think about this in these levels of defense. And let me tell you, that model, having access to that model, arbitrary access to that model, that is effectively a day zero attack, right? They would never allow that. They need multiple levels of security, ensuring identity, assuring authorization, all the way down the line before you even can touch that model. And of course, this is backed by Google, my Google two-factor authentication and making sure that only I have logged into my Gmail password or Gmail account to have access to this, so on and so forth. But I promise you, somebody's going to grab a phone and somehow they're going to get be able to fake authentication of this user, but not have access to the inbox somehow. And they're going to get some suggest attack that I am certain is coming.
Interesting. So this might be a little bit off topic. Fake news is becoming a really, really big challenge going into November in particular. So it seems that is a prime spot for ML to get attacked. And I was curious about if you'd seen interesting work or anything that you're aware of that the larger companies are doing there that you might want to share with the audience.
I mean, they're doing as many things as they possibly can. Actually, let me take that back. They're doing a lot, to say the least. Again, the challenge is that it's very, very hard to explicitly tell the difference between an excellent trained model that is giving you nothing but good recommendations and something that is driving you to deeper and deeper, conspiracy theories and fake news and so on and so forth, right? First off, the place you land is designed to be confusing. Second, the metrics that you use, and remember I touched on in the middle there, your evaluation metrics, that's so critical because, again, imagine, right? Imagine I sat you down and said, I want you to build a recommendation engine. And this recommendation engine, I'm going to measure it based on the number of times someone clicks through, when they click through, if they spend time on that page, and then after that, if they click another one. And imagine you did that and someone spent 3 hours continually clicking through, reading through, not just skipping, enjoying it and moving on. Well, that could be if I was on Bon Appetit and I saw 400 recipes. That's amazing, right? I built the greatest recommendation engine on earth. If I'm on the QAnon, Pizzagate, Comet Pizza, blah, 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 endless degree there, I built the worst recommendation engine in the world, right? I've done nothing but continually jam false information. What's the difference there? The difference is the very, very subtle, the content that was created. Now, again, there are very sophisticated people looking at this, but make no mistake, it is a very hard problem. And especially as we get into these natural language generation things, you're going to start seeing things that have been automatically created, whether or not they're deep fake pictures or deep fake text, which is even easier to some degree, that sound exactly like something that came from the New York Times, except, it happens to be a lie. And boy, it's just a really big challenge.
Right. It seems that part of the issue here is also we don't completely understand the functioning of models, on a theoretical level. So it seems that we're putting Band-Aids on here. So how do you think about the theory needs to progress before we're actually going to find something reasonable?
No, you're absolutely right. First off, a model, certainly not for the foreseeable future, will ever be better than a human. And the fact that humans get fooled by this stuff all the time does give me a lot of hope for Mars. But going beyond that, honest to God, you're never, I hate that, I know I joke and beat up on ML. I mean, it's my space and everything like that. But at the same time, this was already a problem. It really was, right? There was this recommendation problem at, I think it was at YouTube. I can't remember exactly where it was. But they called it oh shoot, I'm totally blanking on the guy's name. Who was the guy who had the most YouTube videos or views of all time? How could I be blanking on it? It was like the biggest thing in history. The Korean guy. I can't believe I'm blanking on it. Anyhow, the problem is that if you don't watch out, every recommendation system in the world is going to result in you ending up on the #1 viewed video, right? It's just, that's the way it goes. And that's not an ML problem. ML will also suffer the same problem, but it's because everyone in the world watched this video. Therefore, everyone in the world, this is a good recommendation for them, or someone else who hasn't watched it yet, just landed on your platform. So, I mean, that's a real problem. It has nothing to do with ML. To your point, though, let's not repeat the mistakes. Let's figure out a way to be better, to measure things better, and to improve and move on. And in many ways, though we are doing really hard work in ML, it's also very, very difficult to debug these things. And you can see some of the things here, but that recommendation problem, if it was just code, theoretically, I could go look at a block of code and say, well, all right, I need to be more thoughtful about how many views matter when it comes to, recommending a video. With ML, I can look at code and not know anything about it because ML isn't just code. It's code plus data that results in totally opaque weights that I could never inspect visually, right? So what do you do there? And that's why building these systems to go and detect what's going on is so important. And things like MLOps that spit out, that not just do training, but then also do very thorough analysis of the statistics that come off this training and record it for me for all time and allow me to build unit tests against it and so on.
Perfect. We have a technical question on the Slack channel that's about manual penetration testing and where does that belong here? Because you can kind of spend all day trying to break an ML model.
Sorry, could you say that again about
manual penetration testing? Yeah, like the traditional testing methods, applying them here because you can keep generating all kinds of data until something breaks your model.
Oh yeah. So I mean, many of the things that you saw here were generated via what are called GAN attacks. It's generative adversarial networks. And that is exactly what you do. I mean, it's not manual; it's obviously automated. But you basically say, I model to result in this response, and then a model. You stick the model over there, and then you continually attack the model using those generated responses until you get the result you wanted, and then you know that it worked. It's a very fast-moving space. It also, by the way, helps generate amazing models, right? I just tweeted about this the other day. They were able to release a new climate model that provides 50 times, not 50%, 50 times better accuracy around solar predictive data. I mean, it's just amazing. I know, it's crazy. Go into my Twitter feed. Or I don't know if I can paste stuff here, but it's just amazing stuff that happens. But at the same time, they're going to be able to figure out attacks where this thing looks exactly like a human being, except for this one little section here, and then all of a sudden it's a lie, right? And so those generative attacks are incredibly important, and it is one of the reasons why defending your model is so important. A lot of those generative attacks require many, many hundreds of thousands of attacks in order to get the model correct or get the data correct. And that's one big reason that a lot of folks will try and steal your model, because then they can take the model, even if it's a 95% representation of your model, to their private environment, and now they can just run attacks against it all night without you ever detecting it, because it's obviously offline. Now, whether or not those attacks work in the original model, obviously that's an open question, but regardless, you get the idea that it does, that kind of vector is going to happen over and over again. And it's up to us to figure out how to minimize that and detect it as best we can.
Got it. We're getting about to time, so maybe we can take two questions. One of them is about resources. So what are your favorite conferences, resources that you like to keep a pulse on for work in this space?
Yeah, it's terrifying. If you go look at the NeurIPS paper submissions, good luck. My favorite, probably by a mile right now, is there's a number of really good newsletters out there that I just read, skim once a day, right? I'm trying to think. I had an article written about me about a year ago, I think, on GeekWire, and I listed them all there. You can go back and look at them.
Oh, nice. Okay.
I'm blanking on a bunch of them. It's way down in the article. It's all about me. You can ignore 98% of the article. Just go down and read the newsletters that I read. But there are a lot of them out there, and they're really, really good. They cover research. They cover why it matters and what's going on. Go and look at. There are so many powerful speakers in our community. You among them. Go out and follow a bunch of people, wherever they are on Twitter or publicly, writing blog posts and so on. And just, if several people mention something, I'm almost guaranteed to go and read the paper. And don't feel overwhelmed, right? The space, unfortunately, is still too math heavy, in my opinion. You can probably get most of what you need just by reading the abstract to get a sense for the research and the things like that. But more and more folks are publishing code, which is a huge area of passion of mine. Go and use a standard repo structure, like Cookie Cutter Data Science has a wonderful repo structure. When you publish your code, encourage others to use that, because if they do, then now you're presented with the code, and it's not just a bunch of Python files. You're like, oh, here's where the data is, here's where the source is, here's where the training scripts are, and so on, and you're able to reproduce that. Back in the day, it was attend a lot of conferences and stuff. Unfortunately, obviously, we're in a bit of a state there, but meeting up with people is hard to overstate.
That makes sense. Awesome. If you have any sort of last parting thoughts for the audience, I think we'd love to hear them, and then we can wrap up.
Yeah, no, absolutely. Like I said, my number one thought, don't invent anything yourself, or certainly not for a foreseeable future. Use things like ModelDB and a lot of the services that are out there. They've really thought about a lot of these hard problems. And if it feels like you're starting something new, absolutely go do it for the exploration purposes, but likely someone else out there has done it. And partnering and extending what's already out there is the best you can possibly do. And I'm always open, really. Like, if you want to email me, tweet, whatever, more than happy to help redirect you. I still feel incredibly brand new to this. I've never published a paper. Well, not an ML paper, certainly. And I'm happy to help redirect you. But at the end of the day, ML is both magical and completely not magical. The best thing you can do is just treat it like another software discipline, and bring these data scientists into that world and help and give them the best software tools, not data science tools, but software tools. Will make your life a lot easier.
Wonderful. Thank you so much. And thank you for the shout out to ModelDB. So for context, folks, David has known about my work and now Verda's work at ModelDB for a while and has been a very early supporter and champion, so really appreciate that. And he himself has done really great work on ML spec and getting standardization in the whole ML ecosystem. So definitely look him up and learn more about what he's up to there. But thank you so much, David, and thanks to the audience for all of their questions too. Let me kind of summarize and wrap up. This was the first of the ML Salons. This was our kickoff. We think that there is a lot of discussion to be had in this space, a lot of bringing the two disparate communities together, data scientists and software engineers. And this is Verda's kind of small effort in this area to make that happen. We hope to have these events every 6 to 8 weeks. Would love to continue the conversation with everyone who was here, whether it was on Twitter, Slack, and we would love nominations for folks that we can invite next time around too. So please engage. We would love to chat. And for those who are into tools, open source, and both kind of commercial, we are going to roll out something on the Verda side soon. And we'll share more of that on the Verda channel in Slack. So thank you again for your time. We hope this was fun. We'll send a survey around after, and we'll love to hear your thoughts. Thanks again. Have a great day, and looking forward to more salons in the future. Thank you, David.
Thank you so much.
See you.